Welcome. This is the video tutorial for Lab 1 Getting Started. I'm in my R environment right now. I'm in RStudio, and I'd like you to know that my environment is set up mostly like I've asked you to do it. There are a couple of differences there. One of the differences is that I've rearranged my windows. I prefer to have the script editor in the upper left hand corner and the console in the upper right. You can make those changes through the global options menu there. You can also resize the windows that are displayed, but that's relatively, I just wanted to let you know that things look a little bit differently in my RStudio environment than what you would see by default. I have a script file open here, and I'm going to go through the script file for the tutorial. I do have you do need to look at the other elements of the module leading up to this one, including good coding practice, or the code style guide, and how to create and run a script file. There's a variety of things there with which you need to be familiar, and I'm assuming you have done all of those things first. So in the script file, every script file that you create should begin with these 5 lines. Obviously you're going to want to put in the correct date and your name and the title for your project here. Since this is Lab 1 Getting Started, that's what I'm putting there. Every comment in R begins with a pound sign, so these are all comments, but the comment with the single apostrophe mark there's certain things that indicate that these comments are for the what's called the metadata for the file that you're going to be creating. Don't worry about that, just put the details of that. You'll see the outcome of that in a little bit, but begin every one of your script files with these 5 lines. I also think it's good coding practice to lay out what is going on in that script file, so you can see that there are 7 different steps that we are going through in this lab tutorial. And the first one is that I want to display the project working directory and the contents of the project folder. The relevant command here is this get WD for get working directory. Commands in R all begin on a line like that. This is an R command, get the working directory, and every command has after it information that's contained in parentheses. In this particular case, there are no additional arguments or options that we need to put into this command. We're just going to display the working directory. And to run this command, there are a couple of ways that we can do that. I typically use Control Enter, but I can go up here and hit Run, and you can see it will run the current line or selection. And so I'll just hit Run here, and you can see that it displays my working directory. So this, I'm actually working in Dropbox, which I don't want you to do, in a courses folder, and in a folder of that called 2420 Stats Lab, and kind of the project is the POSC 2420 Labs. And you can see that information down here in this Files tab as well. So this is my working directory. The second thing I want to do is list the contents of the project folder. Now you're going to see a lot of extra information here, but it lists the directory structure along with files contained in there. It's not, this is just since I already have a number of things in this directory, most of this isn't really important at the moment. You'll see something slightly different pop up in the console here. And I'm going to go ahead and clear the console right now. That little broom command, there's a broom command up here. There's a broom command down here. There are broom commands in various places that are to clear the contents of that window. So I've executed these first two commands. Everything else in here is a comment. The first command is get the working directory, and the second one is list files. I want to do that to ensure that your environment is set up properly. Second thing, I want to see what packages you have installed. So you don't need to know the details of what's happening here. What we're doing is we're creating an object called IP that has that's pulled all of the installed packages and put it as a data frame into this object called IP. And then we're going to take a subset of that, because I have lots and lots of packages, and you'll have a number of other packages installed by default as well. I just want to ensure that these 10 packages are ones that you have installed. So I'll go ahead and run that. And you can see that I now have in my environment down here something called IP. It has 178 observations and 16 variables. If I run the next command, which is the subset, notice I'm now down to 10 observations and 2 variables. And when I run the next command, which is printing that, you can see I have a list of the packages along with the version number of those packages. The last command here, rm, is a command you use to remove objects from the environment. And so I'm going to remove that IP object. Boom. So, like I said, those first two steps are ones that I've designed so I can ensure that your environment is set up correctly, because having your environment set up correctly is going to prevent problems from occurring in subsequent labs. Now, there are these 10 packages that that should be installed already, and we're going to load actually 3 of those packages. I had a typo in there, and don't really need this is I give you instruction in the packages page in this module to understand what's going on here. I like using this command to load all of the packages that I need for a particular script file. You always need to load the packages you need at the beginning of a script file before you use any commands in those packages. And so I find it better practice to load all of them at the same time. And using the pacman command, using the pacman package with the pload command is a way to accomplish that. So this line literally says use the pacman package, and then the 2 colons here mean even though it's not, even though I haven't loaded it yet in this script file, but use the pload command out of the pacman package to load the following 3 libraries: pacman, pander, and tibble. So that's all that does, and if I run that, you will see, in the console it just shows that command. There's nothing magic that happens there. Those packages are loaded. If you try to load a package that you have not yet installed, you'll get an error message here. So if I go back there and I'll just make up a package. I'll call it Ravens, and I'll try loading that, and it'll come back and say installing package blah blah blah. It can't do that because this one library is unspecified. Can't find that, cannot open URL blah blah blah, failed to install load Ravens. So I clearly have an error, a bunch of errors there. So you'll get something like that if you haven't installed a package. But with that, if I'm loading packages that I've already installed, it'll be clean over here. Maybe there might be a note, but you won't get a failure. So, um, like I said, this is just about getting things established. Now, what we want to do is create a data set. And I'm going to show you how to create a couple of different variables. The first one, I want to create a numeric variable. What I'm doing is I'm creating theoretically a team, a basketball team of 6 players, and I want to look at their heights. Their height here, this command on line 53. What this says is I'm going to create a new object called height. This less than sign followed immediately by a hyphen is what's called the assignment operator. It's saying put into the object height the stuff on the right hand side. And the stuff on the right hand side is a list of numbers that are consistent with the heights that I want to enter. Notice it's contained inside this C command, and you can see there are parentheses on either side of that. So this C command is a concatenate or combine command, and so it's saying put into the object height these things, this list of numbers 72, 68, etc. Okay. And you can see once I run that command down in the environment here, you can see there's now something called height, and it's a numeric variable. You can see it actually lists out the 6 values here. I'm going to go ahead and display in the console the contents of that. I can simply type in and run the name of the object, and it will display that object. And you can see there, there are the 6 heights. You can also say print, use the print command to print the object. And you'll see exactly the same thing. There's some reasons why using print might be preferable, but you can see these two produce identical results, and there are lots of ways to do exactly the same thing in R, and this is one of those things. So that's a numeric variable. Now I want to create a character or string variable that's the name of that are the first names of the players. So I have I'm creating a new object here called player, and I'm assigning to it this concatenated list of values, John, Bob, Nick, etc. And notice that for a string variable or a character variable value, I have to enclose that inside of quotation marks. And a couple of other things I'll point out between these two. This is a list, and the list has to be separated by commas. The values have to be separated by commas. Best coding practice says separate, after an operator like a comma, put a space. That results in clean code. Notice down here when I'm creating this character variable, that the comma comes outside of the quotation marks. And the reason is if I had it inside the quotation marks, R would be interpreting that to mean that the value for that thing should be John, comma, as opposed to just John. So when I run this, again, no errors over here, and you can see I now have a character variable called player that has these values. And again, I can print it, and you can see over in the console that those things are listed out. So that's a way to create a character string or a character variable and a numeric variable. So I'm simply creating on the fly here data for my use in R. So that's I have 2 independent vectors floating around, or vectors or variables floating around in my environment here. What I want to do now is I want to combine those into a single data set. And I'm assuming for these purposes that these are sorted in the same order so that John is 72 inches tall and Bob is 68 inches tall, Nick is 76, etc. So in order to create a data set, the kind of data set I'm going to create is called a tibble. Tibble is another kind of object in R. It is a data set that has both rows and columns. So you can think about it like a spreadsheet in an Excel workbook. I'm going to create a new object here called team. We should call our data sets or tibbles. We should name them with an uppercase to distinguish them from variables. So I'm creating an object, a tibble here called team, and what is going into this object is a tibble that's a combination of player and height, those two variables. So I'll run that, and you can see down here I have a new object. It has 6 observations and 2 variables. Notice that this says data instead of values. It's a data set as opposed to a freestanding vector. Now, a way to display, I could display the data frame, or sorry, the data set team. I could simply say, like we did up above, I could say print team. I'll do that, print team, and run that, and notice I get this. It's a tibble, player, height, etc. What I find much better for displaying things is the Pander package. It formats your output in a much cleaner. It presents in a much cleaner way, especially in HTML files. So we're going to use the Pander command instead of the print command, and this is what we're going to use to display the data frame. And it doesn't look really, it looks a little bit cleaner here than the prior one, but it'll look much nicer when we see that in an HTML file. So here are the 6 players and their corresponding heights. Now, I'm going to clean up my environment here. I'm doing this for a variety of reasons, but I want you to remove those variables or vectors from your environment before you move on. So I remove height, and I remove player, and all I have left is team. The reason I do, first, there, like I said, a variety of reasons to do that, but I'm doing that primarily because I want you to be working inside of a data set instead of consistently outside of a data set. So we're going to create a new variable inside the data set that is going to be height measured in centimeters rather than inches. And so this is what I call an absolute reference right here. This team $height.c. So let me show you what I mean by that. I'll give you the difference between an absolute and a relative reference. Remember, up here I could say print height, and I saw that. But I've now deleted height, or I've removed height from my environment. So if I try to print that now, object not found. But that's because I'm making a relative reference. I'm trying to reference something in the environment. But if I make an absolute reference, I say look inside the team data set for a variable called height. I can print that. There it is. So that's the difference between a relative and an absolute reference. The absolute reference uses that $sign. So what I'm doing here is I'm creating a new variable called height underscore C for centimeters, and that's going to be, I'm going to assign to that new object inside the team data set. I'm going to make that equal to team height times 2.54, because there are 2.54 centimeters per inch. Okay, so I'll run that. Notice now my team data set has 3 variables, no error over here. And if I display that now, you can see that I have these 3 values, or sorry, 3 variables. Lastly, I want to display the data set with, with up to 3 significant digits. And I'm going to run that. So I'm using an option here in the pander command. Notice that that takes off everything, just displays height in centimeters and 3 significant digits. So I'm going to come back here and change it to 4. Notice it displays as it did again. So you can adjust the number of significant digits so you get what you're looking for. Typically, there are very, very few circumstances where you need to display more than 1 significant decimal place. Anything beyond that, in almost every circumstance, is just clutters the display and gives the appearance of precision where it's not really necessary. So 1 decimal place at most, for most purposes, is all you need. So last thing for this demonstration, I want to show you how to display some information about the data set. There are 3 commands here: names, dim for dimensions, and str for structure. So if I display the names, you'll see a list of the names of the variables. If I run the dim command, you'll see the number of rows, 6, and the number of columns, 3, or the number of observations and the number of variables. Lastly, if I do the structure command, you can see that this is the kind of object it is a tibble. It's 6 by 3. There is 1 variable in there called player. It's a character variable. You can see the first part of the contents of that variable. Second variable called height. It's a numeric variable. And a third variable called height underscore C, also a numeric variable. So these are the commands that you're going to need in order to complete the Lab 1 assignment. Final thing, what I'd like to do is show you how to compile a report and what you'll get. A couple of ways you can compile a report. You can come down here from the File menu. I typically use this button right here, Compile Report. And when you press that, try that again, there we go. Alright, this pops up. I have some options for output. What you'll always want to use for our labs is the HTML output. Go ahead and hit the compile button. And you'll see a variety of things move past. By the way, the first time you do this, you will get all kinds. It'll take a long time. There are a lot of packages that have to load. Don't worry about that. Just let it run, and at the very end of it, you should get, assuming you have no errors in your script, you should get something like this in the Viewer tab. So notice, here's that metadata I was talking about. The title, Lab 1 Getting Started, the author, and the date. Here are the comments that I have, so it's going through and listing all of the lines, all of the comments and commands in my script file. Those things are in this grayed out area. When I say get WD, the get working directory, it displays the output from the console immediate following a command. Similarly here with the list.files command, it lists the structure of my working directory. Here's what I wanted you to do with regard to the packages. Here's the list of packages, and etc. It's going to list all those things out. And notice how the data sets with the pander command, how nicely formatted they are in the HTML format. So this is hopefully all you need to do to complete the lab. Good luck, and let me know if you have any questions.